Okay, so we've already talked about what a rational expression is. A rational function is where your y value, okay, equals that expression. So f of x equals y. So y equals, okay, rational thing. Okay, so this is just y equals. So don't let the f of x notation mess you up. So just y equals, same thing. All right. And rational expressions, polynomial over polynomial. Poly over poly. This is a polynomial, this is a polynomial. Now you might be thinking, 4, that's a polynomial, that's just a number. Well, it's a very simple polynomial. It's the simplest of polynomials are just regular old numbers. Right? Polynomial over polynomial. These are rational expressions. Okay, and so when you say y equals rational expression, that's a function. Alright, so we talked a bit about functions earlier in the year. We talked a little bit about domains of functions. And so domains of a rational function, you really only have one thing to worry about. The domain is going to be all real numbers except when the denominator happens to be 0. Because if the denominator is 0, your y value would come from dividing by 0, which is impossible. Okay? Don't divide by 0. Bad. So really the work for the problems that we'll do in class are just basically, you can ignore a lot of the information in these problems. You basically look only at the denominator. So 4. Set it equal to 0 and solve. So actually, example A here is kind of dumb. Well, it's good to see a simple one. Never. Okay, so there are no x values that make this true. So what that means is that the domain, and I'll just, because my handwriting's so bad, I'll use capital D for domain. So capital D for domain is all real numbers. Okay, that's all reals is how what's that supposed to say? Or in other words, another notation that we've done is that thing. Or in other words, another notation we've done is that thing. Is this right here, interval notation. Alright, so these are 3 different ways of writing the answer. Okay. I can just use English. Use the shorthand notation or this interval notation. This real short notation we see sometimes. Okay. Alright. Okay, and then we have harder problems here. In fact, I have not left enough space, so let me move C down here, and that will definitely be better. And there we go. Maybe. Here we go. Alright, so C will be down here. Alright, so you set, this one's set the denominator equal to 0. Let me change colors for some contrast. So the denominator is x minus 5. Notice we are not doing anything with the numerators with these problems. Okay, that means x equals 5 is the only thing, and it's a little misleading maybe. This is, our answer or answers are not in the domain. Okay, which is weird maybe. Okay, so what's up? So here that means the domain is, well, I don't want to write it all out, but you could say or write it all out, all real numbers except for 5. That's a legit way of communicating that idea. Alright, but really what I would rather see is one of these things, and just bear with me. So big D for domain. Okay, and we use the brace, it's a curly bracket. It's all the x's. This is what this means. One thing in mathematics is that sometimes notation is confusing. And so here we go. This is an example. So this is all the x's. Okay? Remember it's domain, so we use x. Where x is not equal to 5. It's everything except for 5. Okay, and I know it might be confusing to write it like this because we just said x equals 5. Well, this was just figuring out what to throw out. Okay, we throw out 5 because we throw 5 in here. It's like, oh no, it's a 0 on bottom. Okay, it's I guess 24 on top, not that I really care. 0 on bottom, 24 divided by 0 is undefined. Alright, so you just want to specify, hey, this is the one condition we have on the domain. The domain is everything except for 5. Okay, or in other words, we could write with interval notation. That's from negative infinity. See if I can squeeze this in to 5. But not including 5, if you remember that from way back, or from 5 to infinity. Okay? And we can shade a number line too. Maybe we'll do that, show you that tomorrow in class. I don't have the book with me right now. I don't remember offhand how they tend to write the answers in the back of the book, so we'll talk about that in class. Last but definitely not least, the tough one. In fact, I might just save writing the interval notation. This one will be pain in the butt with interval notation. Set the bottom equal to 0 and solve. So x cubed minus 5x squared plus 6x equals 0. And then, oh no, this looks like a factoring problem to me. Looks like something you guys should be experts at, maybe, from last week at least. So we solve this by factoring. We look for a GCF first. So we get x squared minus 5x plus 6. Okay? And then I'm going to go quickly because the point of this is not the factoring part. This is something we've already done. So if you do whatever technique, AC method's legit. AC method would give us, and you know, if it hurts you for me to skip all the work here, go ahead and do it yourself. Minus 3 minus 2 is what that should end up being. Okay? And so what we do is x equals 0. X minus 3 equals 0. Okay, I would never do this for real. I'll show this, I guess. I would just skip to x equals 3. Okay, and really, once you guys know what you're doing here, which hopefully is already. Okay, that's x equals 3, and then x equals 2 are the three things that you have to throw out. Those are the three things that are not in the domain. So x minus 2, let me skip the works, let me show it. X minus 2 equals 0, so x equals 2. X minus 3 equals 0, so x equals 3. Okay? And so there we go. Those are the three numbers that if you were to plug those in, and it might be a good idea to check to make sure I'm not just making things up. Might be a good idea to check. When I plug those stuff in, you get 0 on the bottom. Alright? So anyway, how do we write the answer? And actually this is a mess, but we'll deal. The domain is all, I could say literally all real numbers except for 0, 2, and 3. Or I could actually write the what's called set builder notation. And you see this a lot. X can't be 0, comma, X can't be 2, and X can't be 3. So it's all real numbers except for those three guys. Okay, anything else is cool. I can plug in any other number, and that's okay for this function. We could figure out a y value if we're super bored. But there you go.